All right, so those are all to your exponential. So an example, if I give you y equals 3 1/2 to the x, right? 3 base 3 1/2 to the x. What's my y-intercept? 0 and 3. Is the graph increasing or decreasing? Decreasing because my b is between 0 and 1. What's my domain? X and element of the reals doesn't change, right? My range? Y is greater than 0. And my horizontal asymptote, which doesn't change for you guys, is that y equals 0. Okay? The next thing we're going to go over is solving exponential. There are 3 ways to solve. Number 1, 4 to the 3x equals 1/8 to the 2x plus 2. Now, remember, I told you if you have 2 bases with 2 exponents, there are only 2 ways I can ask you to solve this. Algebraically, I can ask you algebraically if we can get common base. If we cannot get common base, what do I expect that you're going to do? y1, y2. Okay? So try this one out. You can do common base. All right. What base can we make them both be? Base 2. So I like going and making this 8 to the negative 1 first and distributing that in first. So I'm going to get 4 to the 3x equals 8 to the negative 2x minus 2. Then converting it to base 2. So 4 is 2 squared, the 3x. 8 is 2 cubed to the negative 2x minus 2. So we're going to get 2 to the 6x equals 2 to the negative 6x minus 6. Once you have the same base, you can write them equal to each other. So 6x equals negative 6x minus 6. Add the 6x. We get 12x equals negative 6. You know what's the saddest is when people don't do the divided by 12 and they skip that step and then they tell me it's negative 2 because you divide by 6 instead. So don't skip this step so that you stop yourself from making that silly oopsie. So x equals negative 1/2. Plus, you should have went y1, y2 and checked your answer, right? If you do y1, y2, second trace 5, enter, 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 your x value should be negative 1/2, right? Or negative 0.5. Okay. Second solving. So I give you 3 to the 2x plus 1 equals 7. And I ask you to solve it algebraically. Could I do y1, y2? Technically, to solve it, I could. But if it says algebraically and you do y1, y2, you're not getting the marks because you're not solving it algebraically. You're solving it with your calculator. And the moment you solve it with your calculator, that's graphically. No matter how much you try and tell me that's algebraically, it's not. Okay? So yes, if it's a multiple choice or numeric response, you could totally y1, y2 this and give me an answer, correct? But if it says algebraically in the written response, or it's like, dude does it this way, where did he make a mistake, and he does it algebraically, and you're like, he made a mistake because he didn't y1, y2 it, that's not going to work, okay? People try it. It's not true. Okay, so I can't do common base. So what's the only way I can solve this algebraically? Yeah. Convert it to a log. So I go to my formula sheet, which you'll have tomorrow, and you're going to have y is by itself, the base is always a, the exponent is always x. And so then I write out my lovely formula, which is y equals log base a of x. So you're going to have 7 equals log base 3 Something is wrong. It equals x. I didn't write the formula right. X equals log base a of y. Sorry. I'm like, it needs to be by itself, and it's not right now. Okay. So it's going to be 2x plus 1 equals log base 3 of 7. Okay, then I need to subtract the 1 because I need to get the x by itself. So I subtract the 1. Remember, when you subtract the 1, you have to punch this into your calculator. You're not going to go log 3 base 6, base 3 of 6, sorry. You're not going to do that. And then we're going to need to get it by itself. So we have 2x equals log base 3 of 7 minus 1. And we'll divide our answer by 2. Now, there's still some people who do not know how to punch this into their calculator. That's scary, okay? You can't go into this test not knowing how to punch log base 3 of 7 into your calculator. So if you're that person who's like, yeah, that's me, and you don't have the log base button in math, we draw a line through it like this, and we put a log to the bottom. So please, in your calculator, try this out. See if you get the answer. Log base 7 divided by log base 3. Hit enter. Or if you don't hit enter, you have to bracket these. Minus 1, and then enter divided by 2. So try that out. And you should get x equals 0.39. Divided by 2. Yeah, that's okay. Same thing. Depends on the rounding rules. Yeah, 10th. Then you'd be right. Yeah. Okay. Number 3. I give you 2 to the x plus 1 equals 6 to the 2x minus 3. So some people try their hardest to make this common base. I cannot, in the curriculum 30-2, ask you to solve this algebraically. Because if there's 2 bases with 2 exponents, in order to solve it algebraically, it has to make a common base. I don't have that option. So I have to y1, y2. Try it out. Make sure, unless you have an exponent that pops up, that these are in brackets. So try. Okay. X equals 2.1. Okay. Then what I made you do in exponential is word problems. So I'm going to give you a type of each word problem. Are you given the formulas tomorrow on your test? No, you might be, but that would be like just a gift if you're given it. You assume that you're not given it, okay? First type of word problem. What is that? That was a 3 that just stayed in one spot. Okay. Sam invests $3,000 into a bank at 3.5, that's a percent symbol, per annum. Compounded, which is the key word here, quarterly. How many years will it take for the investment to grow to 4,250? Okay, Sam invests $3,000 into a bank at 3.5% compounded quarterly. How many years will it take to grow to 4,250? So we have compounded quarterly, which tells me I need to use the final equals initial times 1 plus I divided by CP n times CP formula. Okay? We have 4,250 equals 3,000 times 1 plus 0.035. Watch yourself. Don't go 0.35. That's 35%. You're going to get it wrong, and that's like a common thing to do. Compounded quarterly is 4 times a year, and then 4n or 4x. It doesn't matter what you put there. So the very first thing I always do is divide that I over. Yeah, and never round until the very, very, very last step. So you get 0.035 divided by 4 plus 1. So on this side, you're going to get 1.00875. If this didn't stop or terminate, you'd have to like math enter to get a fraction and fill that in. You cannot round even to 8 decimal places until the very last step. Okay? And then we'd have 4x. And x or n is always in what? Years, always. The way we set it up, it's in years always. And then over here we'd have, I just leave it as the fraction, because then I don't have to worry about decimals. Is it 9.9? Okay, so you'll get 9.9, which is 10 years. Now, what happens if it was 9.13? What will we round that to? 10 years. Because remember with time, with the actual amount of years and stuff like that, we always round up because we wouldn't get to there, right? And often the way these questions are worded is, how long will it take for the investment to be at least 4,250? So you know that it could be more, right? Okay, so that's word problem 1. Word problem 2 was there was 10 grams of iodine 131. It doubles every. Now, normally iodine and stuff like that's going to have a half-life, right? But I'm proving to you that it doesn't. Don't just go look at it and be like, oh, it's going to half, because it might not. Okay? It doubles every 30 minutes. How long until there is, are we going to have more grams or less grams? More, because it's doubling. It's getting bigger, right? How long until there is 1,000 grams? Okay, so we're going to get final equals initial rate to the T over P. Remember, P is the time it takes, it's the period, the time it takes to double or triple or half, right? T is the time it takes to reach the final amount. So the final amount is 1,000, the initial is 10, the rate is 2, because it doubles every 3 minutes. You know you need to use this, 30 minutes, sorry. It doubles every 30, so that goes on the bottom. We're looking for the top. Now we divide by our I, just like we always do, and now we're going to have 100 equals 2 to the x over 30. Now, I always just leave my x max be at 100. Sometimes it can be higher, like sometimes the answer is like 225, so then you have to make your x max bigger. But your y max is always just bigger than whatever the heck this value is, because that's a horizontal line at y equals 100, right? So if you don't have your y max at 100, you're at like a little bit more than 100, you're not seeing that horizontal line where the graph is crossing with it. Okay, that's going to be your issue. So what do you get it to be? 199. Is that correct? So 200 what? Minutes. Because whatever P is, T is. Whatever units T is, P is, right? So it was in minutes. So this is going to be minutes. It was 199 point blah, 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 which is 200 minutes. Yeah. Did you put this in brackets? This needs to be in brackets. Your exponent always has to be in brackets. Or else what your calculator's doing is it's going 2 to the power of x and then dividing the whole thing by 30, which is not what you want. Exponent always in brackets. Number 3. Number 3 is depreciation or appreciation. And how do you know to use this formula? Because it doesn't use the word compounding, doubling, tripling, or half-life. So it's kind of like, if it doesn't give me those, it must be the other ones. Especially if it's depreciating, because it's the only formula that really has the word depreciation in it. Now, half-lives obviously are declining, right? But it'll say it. So, Pam bought a car for $23,000. It depreciates 11% per annum. How long until it is worth $10,000? When it's just increasing. So these are the two formulas we have for this, because it doesn't have the word compounded in it, right? So we're either going to do 1 plus the interest to the n or 1 minus the interest to the n. That is what we're going to do. So in this case, because it's depreciating, we're using the 1 minus. So final, 10,000. And your final should be bigger if it's depreciating. I mean, smaller if it's depreciating. Whoa, that didn't, yeah. Anyways, your initial is bigger, so 23,000. 1 minus 0.11 to the n. Now, I'm going to get this divided by 23,000. And we get 10 divided by 23 when you reduce it equals 0.89 to the n. Now, some people are like, if I ask, say I give you this, y equals 2,000, 0.87 to the n. And I ask you, is it depreciating or appreciating? It's depreciating because it's decreasing. Remember, if b is between 0 and 1, it's decreasing. Now, how much is it depreciating by? People will tell me 0.87. That's how much is left. That's not what it's depreciating by. What's it depreciating by? The remainder. So 13. Yeah. Because you just go what? How did you get to this? You got to this because you went 1 minus whatever it was depreciating by, right? So how much does it take me to get back up there? 0.13. You just go 1 minus, so it's depreciating by 13% because I'm losing 13% off the 1. Okay? So people will tell me it depreciates by 87%. No, it doesn't. That's crazy, by the way. Don't buy that vehicle if it's depreciating by 87% a year. Like, that is like the worst. Then buy it after a year if that's what it's doing, because it'll be a good idea. Okay. Y1, Y2. What do you get? Any 7.147? And this is always in years, so it's going to be 8 years. So that was the exponential unit, basically. But remember, the exponential unit is also used in the log unit as well. They kind of work together. So if we do logs, this isn't going to be just logs, but we're going to look at the log graphs. The log graphs are ones that look like this. Remember, you have your vertical asymptote, and you either have the graph depreciating or appreciating. And with the formula y equals a log b to the x, how do I know if it's depreciating or appreciating? Yeah, your a is negative or positive. If a is less than 0, which means negative, it's decreasing. And if a is greater than 0 or positive, it's increasing. What's my y-intercept? None. There is no y-intercept. It doesn't cross the y-axis, right? I have an asymptote on there. What about exponential? What's my x-intercept? There are none because I have an asymptote on my x-axis. Okay? If you're doing something else, make sure you're not. All right. So my x-intercept is always at, for you guys, 1 and 0. Y-intercept, there are none. The domain for you guys, you have no x values here, so and you have no x at 0, so it's x is greater than 0. It's just the opposite of exponential because they are inverses of each other. The range is YER. And I have a vertical asymptote at x equals 0. Okay? Convert from exponential to log. Convert from log to exponential. Convert. Okay, so this is a to the x and then y. So we get x equals log base 3 of 6. And then this is going to be x, a, y equals x to the 6. Okay. Then we did this. Three log ax minus 2 log ay plus 4 log am, because people are partial to my z's and say they're 2's, or then they confuse themselves and are mad. So let's do an m. Okay. I'm going to tell you to do what with this question? Write it as a single logarithm, or I'm going to say what, Kyle? You were right. Simplify. So I'm either going to tell you to write this as a single logarithm or simplify. What's the very first step we have to do in order to write this as a single logarithm to put them together? Get rid of the coefficients. You can't put anything together unless you have plus or minus 1s in front. So I'm going to bring this baby up as a 3, bring this up as a 2 with my power rule, bring this up as a 4. Huge hint that you're probably going to put these together is the fact they all have the same base. So if I put base A, people will spot it. If I put base 10, which means I'm not going to put a base, people don't spot it because they're like, there's not the same base. But it is. It's 10. It's an imaginary base. So watch yourself. Now, the rules to put them together is log base A, x cubed has a positive 1 in front, so it stays on the top. Y squared has a negative 1 in front, so it goes to the bottom. M4 has a positive 1 in front, so it goes to the top. So I can give you that, or I can say expand log 6 x 4y cubed n 3. I say expand. So what do I want you to do at this point? I want you to take it from put together and expand it. Okay? So most people are good at the first step. If they're either really good at this or really bad. They either just don't even attempt it or they just get it right. There's really no in-betweeners on this one. So anything that is on the top gets a +1 in front. Anything that's on the bottom gets a minus. So we're going to get log 6x4 plus log 6y cubed minus log 6n cubed. Now, the answer's not there. That answer is correct, but that answer's not there. What do you think I might do? Put the exponents in front as coefficients. You're correct. Take the 4, drop it in front. Take the 3, drop it in front. Take the 3, drop it in front. So we're just basically undoing what we did on the last one, right? That's all we're doing. So we get 4 log 6x plus 3 log 6y minus 3 log 6n. Okay? What was the last thing we did? We did that, but we went over that already. We did earthquake word problems. Make sure you can do them. And the pH ones. Now, remember the earthquake word problems, the catch is if I is small, then M1 is small. If I is large or greater than 1, M1 is large. So I want you to go over those, and I want you to go over the pH ones, but we don't have a whole bunch of time, and I want to go over a couple things. Okay? 1, make sure you can multiply, divide rationals. 2, remember how to solve rationals. 3, there's a perm or com question. And the last thing I want to go over with you is this. What does this mean? An element of, right? E means an element of, okay? So if I gave you set A is 2, 3, 5, 9, 11. Would this be true or not true? That's untrue. How could I write it so that it was true? 7 is not an element of A. Other thing, what's this symbol? So this means element of. What does this mean? Nope. It's in set theory. It's on the formula sheet. Subset. It's on your formula sheet. Subset. What does subset mean? Sorry? Subcommittee of the committee. What it means is that everything in this letter is a subset of everything in this letter. So say I give you this. A is a subset of B. Okay? A is this. What would B have to have? What would B have to have in order for that to be true? A is a subset of B. Everything in A. Could it have more? Yes. So I could say that B is 1, 2, 3, 5, 9, 11, 1,000. In order for this to be true, everything in A has to be in B. Is this also true? A is a subset of A. Is that true? Yes. A can be a subset of itself. So A is a subset of A. So you have one last unit left. The test will be on the 22nd. This test is tomorrow. And then when you come back to review. If you come back to review and you review hard, and then you go to all these review sessions, you'll do well on the diploma. Your Math 30-2 diploma is a very fair diploma. We can predict what's on your diploma. It's very fair. I actually like the 30-2 diploma. 40. 28 multiple choice, 12 numeric response. Scary part of the 12 numeric response is I wish I could know how many people got it wrong because they rounded wrong. Like not reading to the nearest hundredth and you round to the nearest tenth is usually what happens. So we need to read.